see here we have this equation. Pressure is equal to force divided by area. Right? Pressure is equal to force divided by area. We know that whenever we see something divided by something, this is a fraction. So we know that in a fraction you have the numerator, and in this case, force is the numerator, and in the denominator we're seeing area. Now area, right, is the denominator, and force is the numerator. Just repeat it. Now there is a relationship, a direct relationship between pressure and force, meaning when pressure increase, force increase. There is an indirect relationship between pressure and area. When pressure increase, area decrease. When area increase, pressure decreases. Do we understand that? Are we good to go? Are we clear on this, guys? Good. All right. Here we go now. Here we go, here we go, here we go, here we go. Let's turn to here. Let's go down. So, pay attention to this diagram. This is a rectangle. All right. And we are seeing where the rectangle is applying force because on the surface. Why? Because we see where it sinks. Good? So let's do. Pressure is equal to force divided by area. So if this is applying force, so if I put, let me ask a question in the activity. Let me ask a question in the activity. So pressure equals force divided by area. You know that. Now, on your screen, if I should add another block, what would happen to the surface? And remember, you go to the activities for persons who are just coming in. You go to the lower right hand corner of your screen. You will see the activities button. What you will do, you will click on it and you will go to Q and A. At Q and A, you just click there, and to answer the question, you go down to the lower right of that option, and you see ask a question. You ask a question to answer this question. Okay, I'm sending it off right now. So here's your question. So Golden Genius asks on your screen, if I should add another block, what would happen to the surface? And I'm asking for in the two cases, for the orange brown case and the blue case. If I should add another block to those two sets of blocks, what would happen? Shoot your question, ask your question. Shoot your answers by ask a question. So press ask a question to answer these questions. Go ahead, guys. I'm here looking for 18 replies, please. I guess you're typing. I should see the answers coming in. Right, I know Campbell is here. Campbell, we're doing an activity. You can go in the activities section. That's where you see the lower right, where you see the triangle, the square, and the circle. All right. Please use that option. All right. So Amos, Graham, Shepherd. Not hearing anything from Shepherd. Small, where are you? Christy, White, Virgo. Well, I hear from White. I hear from Christy. Walker, Richards, Smith. Smith, you're lost in the class nowadays, man. I need to hear from you. Come on, man. Okay, someone comes up with it. All right. Boom, 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 boom. McFarlane, Renee Smith, Davis. So Graham is making her answers too. But I need to see your answer right here now, Graham. I hope that is you, Oaksley. So the race is between Oaksley, Graham, Christie, and White. These are the persons who are answering. Grant. Grant is answering also. I think so. Yes. And Francis. So, guys, I need to see your answers. Let me go and see who answered the question first. Now, I after wow, Brian, it will have a greater pressure. I cannot answer as yet. Oh.
What are you doing? Everyone finish answering that now? So the second character is so the red is the sword of Shakespeare and Sonnet.
All right, pressure is inversely proportional to area. So when more pressure is added, the area will decrease. No, you're not answering the question, Mr. Oaks. I asked when I should add more. More. I'm not getting, you're a bit loose right there. I'm going to delete this and ask you to send back an answer. Send back an answer, Mr. Oaksley. I am not liking that answer. The question, Mr. Oaksley, is on your screen. If I should add another block, what would happen to the surface? All right. I guess Graham gets away because I assume that she said it will have a greater pressure applying to it. You need to answer your questions. The key here, guys, is to get you to develop answering your questions accurately. Okay, so I asked you what will happen to the surface. If you say the surface will remain the same, it won't sink anymore, then you'll have to tell me why. If you tell me that all right, it will sink more, you have to tell me the reason why. So the same way how you explain in detail, Mr. Oaksley, that's the same way I expect you to answer, but in a more accurate manner. Okay, Mr. Oaksley? Kai, I am not hearing anything from you. Why is that so? Simit, Christy, where are you guys? You're lost? You're lost? All right, let me just run because time is going. 33 minutes. Here's what we're going to do now. We're going to just run this lesson. So we're seeing, if you notice, there are broken lines here, right? And these represent depth, equal depths. So look what happened if I should add a next block. It sinks to the second line. So we're seeing where more blocks need greater force because we are increasing the weight. And we know that weight is the pull of gravity, that force that results from the pull of gravity. We know that weight is that force that results from the pull of gravity, right? Now, um, let's go. Someone just try entering with the wrong email address. If you're not entering with your Camperdown email address, I won't let you in. All right, so this had 2. So let's go to 3. And we see where the force is increasing. So if force increase from P equal F upon A. So Mr. Oakley, I would expect you would say pressure is directly proportional to force or directly related to force. So if you add more blocks, that means the force increase. An increase in force means an increase in pressure, as Brian had identified. Are we clear so far, guys? If you're not understanding, please raise your hand. If you're not understanding, please raise your hand. Okay, lower your hand. Thank you for that. All right. What we're saying is, when you look on a equation, if there's a fraction on one side, we are seeing a relationship. Pressure equal force divided by area. This is a fraction. Force divided by area. So pressure and force, since force is in the numerator of this fraction, it is in direct relationship to pressure. Meaning if you increase the pressure, you increase the force. If you increase the force, you increase the pressure. Now, pressure and this denominator, in this case, the denominator is the area. Area and pressure are in indirect relationship, or they're indirectly proportional to each other. Meaning when area increases, pressure decreases. When pressure increases, area decreases. Do you understand now? Mr. White, Miss Grant, are you now understanding? Good. How do we know this? I am going to show you the first case. Pressure being directly proportional to force. Remember, W equal mg. Weight is a force. Weight is a force. So if I increase these, I'm increasing the force. And you can see the line going down. You see where it is pressing more into. You see where it's pressing more into the surface because there is more weight. More weight is more force because weight is the force that is caused by the pull of gravity. Force, weight is that force that results from the pull of gravity. We see it over here again. So right here we are proving that if you increase the force, there is more pressure on the surface. If you're not understanding, raise your hand. Who is not understanding? Raise your hand. Who is not understanding? Raise your hand. If you do not understand what I am saying, raise your hand. If you do not understand what I'm saying, raise your hand. McFarlane, I am saying, when you increase the force, the pressure will increase. When you increase the force, and I'm increasing the force by adding more rectangular blocks. See, if I take off a rectangular block, the pressure on the surface decreases. If I add more, I'm adding more force. More force means there's more pressure on the surface. That's what I'm saying. Notice, if I take it off, if it decrease, the pressure on the surface decrease. If I increase the force, the pressure increase. It's like pressing a button. If you do not apply enough force, that button will not press. So the more force you apply, is the more pressure you apply to the button. Are you all understanding me now? Yes or no? All right. I am still getting the common people who are here, still not seeing anything from Simi. Campbell, not hearing from Campbell, not hearing from Amos, not hearing from Graham, not hearing from Shepherd, Small, Christy here, White is here, Virgo, what about Virgo? What about Walker? What about Richard? What about Townsend? Malachi Smith, what about you? Rennie Smith, what about you? David, late just reaching. I hear from Graham, I hear from Oaks this Pauline. I heard from Grant, I heard from Francis. Guys, you are one of the more performing students when it comes to online. Do not fail me now. Do not fail me now. You guys have maintained above average standard for students who are online. Do not fail me now. All right. So we were talking about force and pressure, the relationship between force and pressure. Good? Now, area. Let's consider the area. We are going to call this configuration the first configuration. And we're going to call this configuration the second configuration. When it's lying down, that's the first configuration. So I'm going to call it, I'm going to put in the chat one config, sorry, which is this orientation. All right. So do you agree? Let's go back to the Q&A quick and fast. So people, watch out for the Q&A and next Q&A coming up. Would you agree that both blocks are of the same area? Guys, it's a yes or no. It's a yes or no. It's a yes or no. Y for yes, N for no. Y for yes, N for no. Go to the activity button. Press activities. You see the option come up. You go down to Q&A. Y for yes, N for no. All right, all right. Come, guys. Only 2 persons. We have 21 persons in here. Okay. I see Shepherd coming in. Thank you, Shepherd. I see Davis coming in. Thank you. Smith is here. R. Smith. Malachi Smith, where are you? Thank you. Graham, where are you guys? No, Ken, you cannot come here with that noise. You cannot come here with that. You're going to turn it down. Good. All right. Grant, I see you. Spalding, I see you. Anybody else? Anybody else? Y for yes, N for no. 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 All right. Now, if you agree with what your classmate has said, give them a thumbs up. If you agree with the Y and the N, if anybody have N, if anybody have no, if you agree, give them a thumbs up. So I'm giving thumbs up and I'm not giving thumbs up, you know. Bam, 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 bam. Bam, 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 bam. All right. So I will agree and say yes. I would say Y. Yeah, I would put Y because yes, they're of the same dimension. All right, they're the same height, same width. All right, same height, same width. So the area are the same. If I take a ruler and I measure from up to down, I'll get a number. And if I measure from left to right at the base, I'll get a number. We multiply our length times width equal area. Good? So we would get the same area. Now, with that understanding, this is where I'm getting at now. With that understanding, if I flip this, what do you notice? You are going to use O for orange, B for blue. Which of these, hold on, don't move as yet, stick a button. We are going back into the Q&A. Blue, B for blue, or orange, I cannot spell orange, people. Orange. Good. Blue, orange. And we have O. Which of these are applying the greater pressure? Q&A, people. B for blue, O for orange. 7 wins. Let's go. Let me call the roll call. Let me call the roll call. Let me call the roll call. Now, 1,000, I need to see your answer. So here we go. Campbell, what are you saying? Amos, what are you saying? Graham, what are you saying? Shepherd, Small, Christy, White, what are you guys saying? Virgo, Walker, Richards, 1,000, Smith, McFarlane, Smith again, that is R. Smith, Davison, Blake, Graham, Oaksley, Spalding, Grant, Francis, what are you guys saying? I'm heading over to the Q&A section right now. Let's see. Let's see. O for orange, B for blue. Which of these shapes are applying the greater pressure on the surface? Which of these? Let's see what you say here. Let's see what you say. Now we have an O right here, and we have another O right here, and we have another O right here, 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 we have another O right here. No one saying B, no one saying B. Why? No one saying B, no one saying B. Why? No one saying B, no one saying B. Why? Why is no one saying B? Why is no one saying B? So let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 21. Come on, guys. I need to see more. Need to see. We are at 15 minutes and 21 seconds in the class. I need to see more. I need to see more. I need to see. I need to see. I need to see more. I need to see more. All right. Here's Shepherd coming in with her answer, making it number 10 now. Eat your mango boy. Feed it yourself. So, Graham is right behind Shepherd coming in with her O. No one is saying B for blue. What happened to the blue? It's Champs time. Come on, guys. I say JC. I might say Camperdown too because I work there and my brothers went there. But I'm a blue boy for life. Come on, guys. No one saying blue? Oh, my word. O for orange, B for blue. Which of these are applying the greater pressure on the surface? And I'm seeing all my students saying O. And I will agree with you guys. It is O. Why? You notice that the area of the orange shape that is applying, touching the surface now, the surface area of the orange shape is much smaller than the area of the blue. Good? And for that reason, we're seeing more pressure being applied. Look at it. From the equation, P equals F upon A, we know that if A increases, right, P will decrease. So if area increases, then P decreases, which is what we're seeing in the blue. So the area for the blue is greater, that surface area is greater than that for the orange. So because the surface area of the blue shape is much greater, you're seeing a smaller, much smaller force, pressure being applied to the surface. While in the orange, the surface area is much smaller. So there is a much greater force being applied to the area right there. All right. So here we have proven the two relationship. We have proven that if we apply more force to a surface, we see more pressure being applied to that surface. And we're seeing now where if we decrease the pressure, the area, sorry, we increase the pressure. And we're seeing it right here between both shapes, the blue and the two colored shade, the blue rectangle and the orange rectangle. Are we okay thus far with this lesson? Are we okay thus far with this lesson? Send your answer. Hold on, 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 hold on. Are we okay with this concept? In bracket, that will be the relationship between pressure, force, and air. And then I'll give you the yes, the info no. I love you. All right, so go to the activity button, use the activity button again. Use the activity button again, guys. This time you're going to the poll. And when you go to the poll, press your answer. Press your answer. And the poll is live. The poll is live, guys. Go to the activity button. You press the activity button. Go to the option that says poll. Go there. I am seeing 4. I'm seeing 1 that says no. So I will stop bringing these answers. Let me see. Let me see. Let me see. Let me see. So I know how far back I must go with this concept. So I'm seeing 6 votes, and this is 6 out of 24. I need to out of 22 because I'm here twice. Please send your answers. We're still at 6. We're still at 6, and I'm sure I can tell we're at 7 now. Come guys, answer the question. Answer the question. Are we okay with this concept? The relationship between pressure, force, and area. I'm seeing 8. We're at 8. We still have a long way to go, guys. Half of 22 is 11. Half of 22 is 11. I'm still not at half of the class participating. So 10. 10. 10 persons. I'm sure that 10 persons are live on in class and listening, hearing the words that are coming out of my mouth. If you don't understand, it's a no. If you understand, it's a yes. Come guys, let me know what you're thinking. Let me know where your brain space are. I cannot see who answered the poll, so you know how I'm going to do this. I'm going to say Campbell, Amos, Graham, Shepherd, Small, Christie, White, Virgo, Gutsmore, Walker, Richard, Townsend, M. Simmet, McFarlane, R. Smith, Davis, Blake, Graham, Oakes, Spalding, Grant, Francis, what are your views? What are are you understanding this concept? Go to the poll. I'm only seeing where 10 students are being listening to my voice, hearing what I'm saying, expressing that they understand, expressing that they don't understand. I am at 12. Thank you. I'm a bit over the average now. So listen, I need to see the others coming in now. I need to see the 10 more students. 13. We're at 13. Great. 13 students out of 22 students. Oh, good, 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 good. Let me see these numbers coming in, guys. 9 more students. Come, 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 come. 14 out of 22. Let me see. I am saying to you, when you apply more force to the surface. When you apply more force to the surface, you are seeing more pressure being applied to that surface. And if you should increase the area, you should see an increase in pressure. So I'm saying if you touch a balloon with your finger, that balloon will burst because your finger compared to the pin, your finger has a greater surface area than the pin. So your finger will apply less pressure to the balloon. But if you use a pin that has a very small surface area, you will apply greater pressure to the balloon, hence the balloon will burst. That's what I'm saying to you. Are you understanding the concept? That's what you're seeing in front of you. The blue block would be my finger pressing on the surface of the balloon. It won't burst. What I'm seeing, if I should use a needle, which I could say is the orange rectangle, then the balloon will burst because I am applying more pressure to the balloon. Some guys, are we understanding? I'm seeing 15 students out of 22 students expressing that they understand or they don't understand. Come guys, come guys, come guys, come guys, come guys, come guys, come guys. And I hope that one person who said they don't understand, I hope are now understanding. Moving on, moving on. We are at the 1 hour mark and an hour to go for class. We are at the 1 hour mark and we are welcome, Miss Fagan. You are an hour late for class. We start class in the regular on the campus down about, and we were there for nearly half hour before. Well, not nearly half hour, but getting nearly up to half hour before, and you weren't there. You're late for class. You're late for class. You're at 1 hour and 50 seconds in class. Now, moving forward, I will end this poll and I'll introduce the next concept, and I hope the next concept that I introduce, when I ask for a set, when I start assessing, evaluating your level of understanding, I'll get a better, much more participation from the class. Okay? All right, as I said before, my background is noisy. I'm home with the kids, and I live near to the roadside, so trucks are going to be passing, vehicles are going to be passing, and my son and my daughter, especially my son, will ensure that the class remains lively. Anyway, moving forward. Now, I want to walk you through. I introduced this concept on the board, and persons were like, wow, sir, I make up this, you know. I introduced this concept on the board, and persons were like, oh, wait. All right, I have expressed that you don't need to know it, but in the case that you go on my website and you see this long working out, and you're asking yourself what it is, let me explain it quickly for you. All right? Now, so far we know that at number 1, P is equal to F upon A. Pressure is equal to force divided by area. We should have no problem with that because that is the definition for pressure. Pressure is equal to force divided by area. The perpendicular force applied to that surface area. or force applied to a perpendicular area. All right. The key right here is that both the force and the area are perpendicular to each other. That's what why I'm stressing. Now, F is equal to ma. Force is mass times acceleration. If we want it, we know that weight is a force. And what is the formula for weight, which you are seeing in red? Is W is equal to mg. W is equal to mg. So force is equal to mass times acceleration, and weight is equal to mass times acceleration due to gravity. So let you guys know that this is where I'm working. I put it in red, and I am letting you know that I should have W right here, which is W is equal to mg, right? Because weight and force are the same thing. Weight is measured in Newton, force is measured in Newton. I'll show you how I got that. Right? Now, we are now at, if I should replace the F with mg, because that's what the F means, mg, I will now have at number 2, P is equal to mg divided by A. Are we following so far? Create the next. Are we seeing how I got P equal mg divided by A? Yes or no? I am not sending this option, so I will launch. Are you seeing how I got P equal mg divided by A? Go to the pole. So I am saying P equal F divided by A, but F is equal to mg. So where I have F, I replace it with mg. Hence the reason why you're seeing P equal mg, which is in red, to show that F was there, but the meaning of F is mg divided by A. The meaning of F is mg, and I just replace the F with mg and just continue dividing by A. Are you seeing how I get P equal mg divided by A? Please go to the pole. Please go to the pole. All right. I am going to end the poll right here. I'm going to close it up, delete that. I'm going to ask it again. Are you seeing how, and I'm going to say equation 2, seeing how I got equation 2. And that is yes, no. Before I ask the question again, let me just repeat. P is equal to F upon A. But F is equal to mg. So because mg is weight and force is weight, so I replace F with mg. P equal mg divided by A. P equal F in equation 1, P equal F divided by A. So what I do, I let you know that F is equal to mg. So where I see F in the equation, I put mg, and that results in me getting equation 2, which is P equal mg upon A. If you're not looking on the screen, please do not answer. You should be paying attention to the screen. It's right here in front of us. P is equal to F upon A. F is equal to mg. So wherever I see F, I put mg, and that I continue to say mg divided by A. So that is my second equation for pressure. So I just got a new equation. So if this is what I'm saying. If I get the force, I can divide the force by the area, and I get the pressure. But suppose I don't get the force, but I got the mass. All I need to do is multiply the mass by the acceleration due to gravity, and we by now know that it is 10 meters per second square, or if it says the gravitational field strength, which will be 10 newtons per kilogram. So, but in both cases, all I need to do is get the mass from my scale, multiply it by 10, and divide it by the area. That's what equation 2 is saying. Now I'm going to ask this question. Please look in the poll. Answer that question. Are you seeing how I got equation 2? I have 2 volts. I have 2 volts. Class, are you seeing how I got equation number 2? P is equal to mg divided by A. P is equal to mg divided by A. Are you seeing how I got it? All right. I am at 6. Students, pay attention to your screen. Are you seeing how I get P is equal to mg divided by A, which is equation number 2. I am at 7 volts. Or I should say I'm at 7 answer. I'm at 9 now. Students, I am not getting everybody participating in class. We are just logging in, not paying attention. You cannot complain that I'm just talking. You have, this class is in your control, it is in your hand. Thousand, Simic, McFarlane, Williams, Rennie Simic, Davison, Blake, Graham, Oaksley, Fagan, Spalding, Grant, Francis. I am not seeing all students. I am seeing 9 students. Persons who have answered the questions, raise your hand. Persons who have answered the question, raise your hand. Please lower your hands. I am glad I'm doing this. I am glad I am doing this. I am seeing who is participating in class. Thank you, Smith. Thank you, Spalding. You can lower your hands. Good. Glad I'm doing this. Now, the persons who say they don't understand, raise your hand. If you don't see how we get it, raise your hand. The 4 persons who do not see how I got it, raise your hand. I have 4 persons saying that they don't see it in the chat. I'm in the poll, but I'm seeing 5 persons. If you did not identify on the poll, please use the poll to put in your no. I am seeing 5 persons, and the poll is telling me 4. Pauline, Richard, Small, and this is Graham. Are you lower your hands? Look at equation number 1. P is equal to F divided by A. F in that equation. Small, lower your hand. Small, lower your hand. Small, lower your hand. Now, F is weight. F is weight. Force in equation 1 is weight. And to find weight is mg, mass times acceleration due to gravity. So where I see F, I just take what F means. F is weight, and weight is equal to mass times acceleration due to gravity. So mg, when you calculate mg, you're still going to get F. That is mass times acceleration. That is the amount of mass that you get on the scale multiplied by the acceleration, which is 10 meters per second square, or the gravitational field, which is 10 Newton per kilogram. So we are now at P equals mg upon A. Do we now understand? Small. If you still don't understand, if you still do not understand, raise your hand. It is what we call substitution. It is what we call substitution. So what I do, I substitute mg into equation 1. So where I saw F, I put in mg. So the new equation now becomes P equals mg upon A, and I'm at number 2. Are we good now? So I add small, I add Graham. So the persons who did identify that they did not understand, are you understanding now? Yes or no? Small and Richard, 3 more persons. Where are you? Are you now understanding? The other 3 persons, are we understanding? So small, Richard, small it. Guys, persons who are not paying attention, not participating in class, keeping up the class. You're saying you're not understanding what when you're asked if you understand, you're not identifying yes or no. Thank you, Brian. So we have small, Richard, 1 more person. Thank you. Now, the same thing that we did, we are going to do again. We're going to make another substitution. Because we see where we can make another substitution. How can we make another substitution? A, the area. Now, height, length, width, breadth, distance, they're all the same thing. They're all the same quantity. They are distance, they are length, right? So I can say, because look at this. Look at this. When I turn this on the, when I put it to lay down, the height is right here. The height is on the left, the height is on the right, right? When I put it to stand up, that same base that was laid down, it now becomes the height. So I can say in all cases, I am saying that this, the short side can be height. Also, I can put it where the long sides are height. So I can just say they are both height. You get that, guys? We understand that? I can say the long side is a height because I can set it to become the height. And the short side, I can set it so it becomes the height. We're good with that? We're good with that, guys? Yes, no, Y for yes, N for no, guys. No one hear me? Are we okay with my explanation? I can make the long side of the rectangular box the height. I can also make the right the short side the height. So basically, it's height times height. And I can get the area. Are you guys hearing me? Are you guys agreeing with me? Yes or no? Y for yes, N for no. Thank you, Christy. Anybody else? White, Oaksley? No agreement, Fagan? Smith? Campbell? When we are in class, we are all talkative. This is time to be talkative now. Good. Now, where I see A, I can put I times I. I times I will give me I squared. Anything multiplied by itself is squared. So where I see A, I will now put H squared. Where I see H, I put H squared. So if I'm given something and I get the mass and I get its height, or I can find the area. As long as I can find the area, right? Because the regular shape, I can now find the pressure because what I'm going to do, I'm going to multiply the mass by the acceleration due to gravity, which is in red, and I'm going to multiply the height by itself, which is height squared. So I am now at a third equation. I'm now at a third equation. Which is P is equal to mg upon h squared. Are we seeing that? So the next question is, see how I get equation 3. Yes? The poll is in the chat, guys. Are you seeing how I got equation 3? One person answer it. Two person answer it. Are you seeing how I got 4 person answering? Answering yes, that is good. Even if you say no, that is good because I know where we stand. Pressure is equal to force over area. The equation for force is F multiplied by A. The formula for, so let's go over. Equation for force, since force is weight is equal to mg, so I take mg, put it in the numerator. Area is equal to height squared, so I put height squared in the denominator. And we see 7 persons are seen out of 20, out of 23 persons. I'm at 8 now. Are you seeing that? We're going through this. We're going to make something of ourselves. This level. We're learning some CXC maths. Guys, this is the beauty of maths. P is equal to mg upon h squared. So I can use equation number 1, which is force is equal to pressure is equal to force divided by area. And use equation 2, which is P is equal to mg upon A. We can use equation 3, which is P is equal to mg divided by h squared. Are we seeing these things, guys? Let me know, yes or no. Yes or no. We are at 1 hour and 26 minutes in the class. We are at 1 hour and 26 minutes in the class, and I'm sure because we were in Camperdown's account, we are going to be out of. We are now just 1 hour and 27 minutes in class using my account. Now we are almost there. We are almost there, guys. We're almost there. Now, this is where it gets. I'm going to cut this 8 for 8 persons have been paying attention right here. So I'm going to cut it. Please. Roll call again. Campbell. Not hearing anything from Campbell. Amos. Ryan. Shepherd. Small. Christie. Virgo. Gutsmore. Walker. Richards. Townsend. M. Smith. McFarlane. Williams. R. Smith. Davison. Blake. Graham. Oaksley. Fagan. Smalling. Grant. Francis. Please, 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 please pay attention. Please, please pay attention. Please, please pay attention. Please pay attention. Give me a minute, guys. Sir. Yes, sir. When I reach that school yet, my soon go and drop it off. Yeah, we never come. I have class 2 for a session. I'm just around out the class for drop class. Alright, when that class I don't running. Huh? No, no. Ah. All right, guys. So this is where it's going to get a bit technical, and this is the reason why we won't require for you to remember this at this level. All right. Now I'll just tell you. Now what I'm going to change right here is the math. So I'm at equation 3. But what I'm going to change is the math. I'm going to allow the g to remain, the h squared to remain. But I'm seeing where I can manipulate, I can do something with the f. And what do? I know that mass is density times volume. Mass is density times volume. So when I put density times volume here, right? When I get density times volume, volume is V is equal to H cubed, because area is when you take a distance times a distance times a distance, you get distance. No, distance times distance, you get distance square, which is the same as H square in this case. Now we're dealing with volume. Length times length, or height times height. So height cube. So what I do now, I know that mass is equal to density, which is this P looking thing. It's called rho. We call it density is equal to volume, but the volume is not V. The volume is H cube. The volume is not V, it is H cube, because volume is H cube. So what I do now, I put P is equal to rho H cube times V. So M right here, is rho density times volume. That's what this funny looking P and the H mean. All right. Are we seeing how I get P equal rho H cube G? Are you seeing that? All I did is take this equation, remove the V from this equation, put H cube there. I am now at M divided by H cube. Then I change the equation so that M is equal to PH cube. And that's what M means. M, look at equation number 3, where is mg rho g cube is M. So that's what I put it here. Now I have 3 H's on the top. I have 2 H at the bottom. So it cancels out 2 at the top, leaving 1 H. Now, with all of that, you don't need to remember all of this at this level. You just need to know that when you're finding the pressure in water, in liquid, or in gas, the pressure that is coming through the pipes, the pressure in a balloon when you blow up the balloon, the pressure in the gas tank, then you buy the gas, it is calculated equal using this equation. P is equal to rho GH. Rho is density, H is height, and G is the acceleration due to gravity. And I will repeat, when you are finding pressure in fluid, and fluids mean gas or liquid, we use P is equal to rho HG or rho GH. You might see if the G and the H in different position in different depth. But we do not use P is equal to force of an area. All right? We talk about the density, the height, and acceleration due to gravity. That's what we're bringing up. And this can be seen. I see if I have it on this website. This can be seen right here. So what I'm saying, each fluid, so gasoline has a density, right, of 700 kilograms per meter cube. Water is 1,000 kilograms per meter cube, and honey is at 1,420 kilograms per meter cube. So we have three liquids of different densities. Are we seeing that? Are we seeing this, guys? Are we seeing this, guys? All right. So this is the density. And remember when I talk about, I was telling you that it's rho GH. So this box up here represents rho. This thing that looks like P, that's the density. Now, gravity, acceleration due to gravity on Earth is 9.8, and we can roll it off to 10. Like what I tell you to do, 10. All right, so we roll it off to 10. And then I told you that rho times the height of the liquid multiplied by the acceleration due to gravity gives you the pressure. So in the atmosphere, in the air, this is the pressure. 103.377 kilopascal. Good? Now, let's take the height of this liquid. Remember someone told me that when you increase in depth, the pressure increase. So I go down, the pressure should increase. So at 0, I am at 104.319 kilopascal. At 1 meter down in the water, I am at 114.167 kilopascal. At 2, I am at 124.264 kilopascal. You can wait here, I'm teaching. Can you wait? Jesus. Now, at level 3, I am at 133.488 kilopascal. Now, let's see what happens when I run out the water. Let's pull it up back. Take my time. You notice that as the depth decreases, the pressure also decreases. And here, I am back at here, right? So are we understand the concept of, are we understanding now the concept of pressure increasing with depth? Do you understand the concept that pressure increases with depth? All right. I know you might be, I know we're going through a lot. As usual, this will be available to you guys. So let me just run the poll again. Let me just run the poll again. Do you understand that pressure increases with depth? Guys, okay, two persons. I guess we don't answer the question because we're saying Mr. Ethan don't know if we're really answering or not. But I am too seeing the amount of person answering, and now I'm only at 6 persons who are still active in class.
No, at 9. All right, as soon as you answer your question at the phone, you may leave. As soon as you answer, you may leave. Respect Oakville, respect. I mean answer it in the poll. If you don't answer it in the poll, I won't have it as you participate in the class.